Have you ever wondered how a small jack can lift an entire car? It looks so simple, yet it is powerful enough to raise loads many times heavier than itself. In this video, we are going to explore the secret behind this amazing device, the hydraulic jack. We will go through how it works step by step, what components it has, and why it is such a useful tool. The working principle of a hydraulic jack is based on Pascal's law. Pascal's law, also called Pascal's principle, states that a pressure change applied to a confined, incompressible fluid is transmitted equally and undiminished in all directions throughout the fluid and to the walls of the container. In other words, a small force applied on a small piston can create a much larger force on a bigger piston, making it possible to lift very heavy loads. To clarify, here is a simple animation of Pascal's principle. Let us assume P1, F1, and A1 for the small piston, and P2, F2, and A2 for the large piston. According to Pascal's principle, pressure is the same throughout the system. That means the pressure at piston 1 is equal to the pressure at piston 2. Pressure is equal to force divided by area. So, we can rewrite the equation like this: force 1 over area 1 is equal to force 2 over area 2. If we rearrange the equation, force 2 becomes area 2 over area 1 times force 1. For example, if the area of the large piston is 50 times the area of the small piston, then the output force is 50 times larger than the input force. When a small force is applied on the smaller piston, it creates pressure in the hydraulic fluid. That pressure is transmitted equally in all directions and pushes against the larger piston. Even though the input force is small, the larger piston is able to lift a heavy load because of the multiplied force. This is the basic principle behind every hydraulic jack. Now, let's understand how this principle is applied in a hydraulic jack. When the smaller piston moves upward, it creates suction and draws oil from the reservoir into the pump chamber. When the piston moves downward, it pushes that oil from the pump chamber into the main cylinder. This process is controlled by two one-way valves. During the upward stroke, the suction valve opens to allow oil to enter from the reservoir, while the delivery valve remains closed to stop oil from flowing back from the main cylinder. During the downward stroke, the suction valve closes, and the delivery valve opens, allowing oil to be forced into the main cylinder. This pumping action repeats with each stroke, transferring more oil into the lifting chamber and gradually raising the ram. Finally, when the operator wants to lower the load, the relief valve is opened. This valve provides a pathway for oil to flow back from the main cylinder into the reservoir, allowing the ram to descend smoothly to its original position. To carry out this cycle, the jack contains several important components. A reservoir, where the hydraulic oil is stored. A small pump cylinder and piston, which perform the suction and delivery strokes. Two one-way valves, the suction, inlet, valve and the delivery, outlet, valve, which control the fluid direction. A large cylinder and ram, which actually lift the load. A release or relief valve, which returns the oil to the reservoir for controlled lowering. And of course, the pump handle, which provides the manual input force. The hydraulic jack is simple, portable, and very powerful compared to its size. However, it requires regular maintenance, can be slower than mechanical jacks, and may leak oil. Next time you see a mechanic lifting a car with a hydraulic jack, you'll understand the science behind it. This was E-Tech, making engineering simple and clear. If you found this video helpful, don't forget to like, share, and subscribe for more mechanical insights.